Hey guys, Miss McMahon here. I wanted to start by going over some things that we've been working on so far. So first we reviewed and practiced dimensional analysis, which is the process of converting values from one unit to another, or sometimes converting multiple units simultaneously. For example, if something is in miles per hour and we want to convert it to inches per minute or something similar to that, that conversion process would be called dimensional analysis. And what I hope you noticed while you were practicing that is that we were consistently multiplying by values of 1 so that we didn't change the value that we started with, and we simply changed the look of that value by converting it through those units. The second thing that we did is look at what a radian angle is. When we have one, what needs to be in place to have a radian, which is just that the length of the radius of the circle needs to be measured along the arc of the circumference of that circle, and that creates an angle that is 1 radian. We looked at how many radians we had in a circle, which made it possible for us to compare radian angles to degrees. So that's where we are up to this point. We've looked at and practice those two things, and now we're going to connect them. How are those two things connected? Why did I have you practice dimensional analysis right before looking at what a radian angle is? And that brings us to question 10, which you're struggling with if you're watching this video, and I don't blame you because I am going for such a particular answer here that I'm trying to, in this question, I'm trying to guide you down a very direct path without giving you the answer. So I can totally understand if you're struggling, and I'm happy to help you with that. So starting just by reading the question, of course, and making sure we remind ourselves what it is and we understand it. So we know now that 180 degrees equals pi radians. So those are the angles of a straight line written in 2 different units. Or that 360 degrees equals 2 pi radians. So that would be the 2 angle units of a full circle. Knowing that, how can we manipulate the equation to write different but equivalent forms of the equation to use for unit conversions? Explain why this expression/equation will help with question number 11. So I'm going to move that over here, not too far away. And I'm going to rewrite our general equation that we have, which is 180 degrees equals pi radians. And as question number 10 says, we're going to manipulate the equation to write a different but equivalent equation, a different but equivalent form of the equation to use for unit conversions. So there are a bunch of different ways that we could manipulate this equation. What we're going to do today is we're going to divide both sides first by 180 degrees. Now, first of all, if we do the same thing to both sides, our equation is going to continue to be equivalent. And second of all, if we divide both sides by 180 degrees, we're going to get, on the left side, we're going to get 180 degrees divided by 180 degrees. Anything divided by itself will cancel out to be 1. So that will get us 1 equals pi radians divided by 180 degrees. Similarly, if we take the same initial equation that we know to be true, 180 degrees equals pi radians, because again, this is the same angle measure, specifically of a straight line, in 2 different angle units. So it's going to be equal measurements, just in 2 different units. And this time, we're going to divide both sides by pi radians. Sometimes people write rad or RAD for short. Divide both sides by pi radians. That would get us 180 degrees divided by pi radians equals pi radians divided by pi radians. And again, anytime you divide something by itself, you're going to get those things will divide out to equal 1. So what we have here are 2 fractions. In fact, they're not just any 2 fractions. These 2 fractions are reciprocals of each other, because that is the name of what we call a fraction that has been flipped, where the numerator and denominator switch places, and we definitely see that in this example. But we have 2 fractions that are both equal to 1. Now keep in mind that the reciprocal of 1 is also just 1, so that reciprocal relationship also holds true with the values of 1. But again, the 2 fractions are equal to the value of 1. That means that if we take these 2 fractions and we multiply them by any value, we will not change the value of that number. We might change the look of it, but we will not change the value of that number, because when you multiply anything by 1, that thing stays itself, right? We know when you multiply anything by 1, that thing stays itself. So we have pi radians divided by 180 degrees, which you can and will see people start to sort of drop the units of radians and degrees. And again, the reciprocal of that, 180 degrees divided by pi radians, are both equal to 1 and can be used to multiply by numbers to change the look of the number, but not the value of the number. So as we move to question 11, as we move to question 11, keep in mind that if you are starting with the degree angle and you want to convert that to radians, you can multiply by either version of this fraction here, 180 divided by pi, or pi divided by 180, to get to the other angle unit, to get from degrees to radians, or also to get from radians to degrees, if that's the direction you're trying to convert to. When you do this, you need to think about what unit am I trying to introduce to the scenario, and what unit am I trying to cancel out in this scenario to make the conversion, to go from whichever direction you're going to wherever you want to go. Again, degrees to radians or radians to degrees. And that will help you choose which fraction, which version of the reciprocal you want to use based on how we multiply fractions together. Do you want to introduce radians in the numerator and divide out degrees in the denominator? Or do you want to introduce degrees in the numerator and divide out radians in the denominator? So with that, I would say take a look at question 11 on your dimensional analysis worksheet. Give it your best. And if you are still struggling with that, there are more videos to support your learning. All right. You'll be able to reach out to me if you have questions. But other than that, good luck and let me know what I can do to help. Thanks, guys. Bye.